Hi, everybody. It's 2 o'clock Brussels time, and I want to welcome you all back to the 7th European Marine Board Forum on Big Data and Marine Science. This afternoon's session, session 2, is on the EU Biodiversity Strategy and how big data can actually help us with that. Can we have the next slide, please? Just a reminder for everybody new and those of you who have been here before. For housekeeping rules, please use the chat if you have any technical problems, and use questions and answers for the questions. Please remember to have your name in there and to state who the question is for. And then once we get to that section of the program, I will read out the questions to the speakers and panelists as they come in. One last reminder is that this webinar is being recorded and it's being live streamed on YouTube. And the recordings will be available on YouTube after the forum. Just for those of you who don't know. So our speaker this afternoon is Sakina-Dorothee Ayata. She is from Sorbonne University, and she's an associate professor in marine ecology at the Sorbonne University. She's got a background in ecology and computer sciences, and now she works on how numerical models and tools can better she can use them to better understand structure and functioning of marine life in the ocean. And we are going to play her video now, if possible.
Good afternoon, and thank you for attending this online meeting organized by the 7th European Marine Board Forum. My name is Sakina-Dorothee Ayata. I am Associate Professor in Marine Ecology at Sorbonne University in the laboratory of Villefranche-sur-Mer in France. In the past 15 years, I have been using numerical tools such as models and statistics to study the distribution of marine biodiversity. More recently, in our lab and together with European and international colleagues, I have been exploiting marine big data such as online databases of species occurrences, metagenomics data or imaging data, in particular through machine learning, to study the biogeography of marine plankton. I guess that's for this reason that I have been invited today to talk to you about the role of big data, digitalization and artificial intelligence in the conservation and restoration of marine biodiversity, in particular in the framework of the EU Biodiversity Strategy. Marine biodiversity encompasses a puzzling diversity of ecosystems, such as coralligenous habitats, intertidal reefs, kelp forest, or marl beds, and also life forms, from unicellular organisms to whales. This taxonomic and phylogenetic diversity also fosters a huge functional diversity. It means that marine organisms contribute in many different ways to ecosystem functioning and biogeochemical cycles, which provide important ecosystem services to human societies. Indeed, as you may know, marine organisms provide half of the oxygen we breathe and contribute to the storage of atmospheric carbon released by human activities, hence contributing to climate regulation. For instance, marine plankton sustains the export of about 0.2 gigatons of carbon per year. Marine ecosystems also provide food, and about 1.4 billion people rely on fisheries for their primary source of protein. Finally, marine ecosystems also contribute to recreational, educational, and spiritual benefits, since marine ecosystems have inspired the cultures and traditions of many societies, and now support coastal and maritime tourism, which employs almost 3.2 million people in Europe and generates 183 billion euros in gross value added. Yet, marine biodiversity undergoes many threats, including overfishing, habitat degradation and destruction, pollution, invasion of alien species, and climate change that is responsible for temperature increase, sea level rise, ocean acidification, and more frequent extreme events. The loss of marine biodiversity has a cost for human societies, hence there are tremendous economical and social costs of inaction. For instance, the conservation of marine stocks could enhance the profits of the seafood industry by more than 49 billion euros per year, while the protection of coastal wetlands could save the insurance industry about 50 billion euros per year by reducing flood damage losses. In that context, the EU Biodiversity Strategy aims at protecting at least 30% of European seas and at restoring degraded marine ecosystems. The first objective of the EU Biodiversity Strategy is to protect at least 30% of European seas through MPAs, marine protected areas, which is at least 90% more as compared to today. It also targets strict protection for at least 10% of the European seas, especially for the areas with very high biodiversity and climate value, such as seagrass meadows or mangroves. These MPA targets also include tropical and subtropical ecosystems in the EU's outermost regions and overseas territories. As a consequence, new MPAs will have to be identified, managed, monitored, and their efficiency will have to be evaluated. The second objective of the EU Biodiversity Strategy is to restore degraded habitats and ecosystems across the EU by 2030. It aims to focus in particular on ecosystems playing a key role in carbon storage and contributing to the prevention of natural disasters. This second objective includes the decrease of human pressure on marine ecosystems, the development of sustainable fisheries, especially by reducing bycatch of endangered species and by limiting the impact of fishing gear on marine biodiversity, win-win energy production, such as the development of offshore wind farms that favor fish biomass concentration, the reduction of marine pollution, including marine litter and underwater noise, and the limitation of invasive alien species. Finally, the third objective of the EU Biodiversity Strategy is to enable a transformative change through a new governance framework, building on an integrated and whole-of-society approach, including businesses and citizens. In that context, how the use of big data, digitalization, and artificial intelligence may contribute to achieve these ambitious objectives. I will now show you some examples on how this could be done, firstly for defining and monitoring new MPAs, and secondly for monitoring bycatch to pave the way towards sustainable fisheries. So, how data science can be used for efficient marine protected areas? First, it can contribute to the definition of new MPAs by identifying biodiversity hotspots. This could be done through mapping plankton diversity with high-throughput in-situ plankton imaging system, such as the one we developed in Villefranche-sur-Mer. Here, automatic plankton identification from a large number of individual images is made possible through machine learning. Other types of marine data can be used to map the seabed, such as hydroacoustic and satellite data that can be combined to map shallow nearshore benthic features, for instance. Finally, online databases of species occurrences can be exploited and combined with machine learning-based niche modeling to identify the biodiversity hotspots that are the most sensitive to climate change. This is also the type of studies that we have been doing in my lab in the past few years. In a second step, data science can be used to monitor these newly defined MPAs and quantify their efficiency. Using the approaches I've just mentioned, marine biodiversity can be monitored using standardized observation methods, especially through the definition of new bioindicators based on the automatic acquisition of high-throughput data, especially from images, genomics, satellite, or acoustic. Satellite and acoustic data can further be used to monitor fishing activities and illegal vessels within the MPAs using classification methods. The second example I have chosen deals with the use of computer vision to analyze videos from the CCTV systems of fishing trawlers in order to quantify discarded fish catch. The aim here is to automatically monitor fishery discard to ultimately decrease the impact of fishing on marine biodiversity. This example comes from an article published this year by French and colleagues. Here, the main challenges are to develop a tool adapted to various CCTV setups. Then, to be able to isolate and segment individual fish. And finally, to classify the individual fish into species, even when some parts of the fish are missing from the images. Here is a very nice example on how the use of deep neural networks can help the analysis of fisheries surveillance videos to automatically monitor fish discards and hence contribute to the development of sustainable fishery. Finally, to achieve the third objective of the EU Biodiversity Strategy, that is to enable a transformative change through a new governance framework, one option would be to develop a EU-wide methodology to map, assess and achieve good condition of marine ecosystems. As I mentioned earlier, this could emerge from the definition of new bioindicators from the machine learning-based analysis of marine high-throughput data, especially from imaging and metagenomics. Here, the development of autonomous observation platforms could play a central role. It would then provide a data-driven support for decision-making towards stakeholders, such as MPA managers, but also governmental and European organizations. Such bioindicators would have the advantages of being automatically estimated through standardized protocols. And they would help decision makers in Europe to select and prioritize species and habitats that need protection and monitoring. To conclude, I will just underline that data science offers tremendous opportunities for marine biodiversity research and should contribute to the protection of marine biodiversity in Europe. As stressed out by the 7th European Marine Board Forum in its future science brief on big data in marine science, it will require further collaborations between marine scientists and computer scientists, including through the development of specialized training for marine scientists. Finally, the EU biodiversity strategy also aims to promote the monitoring, conservation and restoration of biodiversity beyond Europe, especially to lead the world towards the adoption of an ambitious global biodiversity framework. I hope that I have convinced you today that data science should actively contribute to this endeavor. Thank you for your attention and thank you for the organizer.
Thank you very much, Sakina. And there we are. We have you +1 there, which is great. I hope we don't wake the baby as we ask questions. I'm not seeing any questions yet in the questions and answers, but I have one for you while people think of their questions. Specifically on the fisheries surveillance videos that you were talking about earlier. I wonder if you can let us know, how do you think, or do you know how good they are at actually making sort of predictions of, say, invertebrates? You know, I know that especially in trawl fleets, they often trawl up quite a lot of invertebrates, and we don't have very good data of the biomasses and the abundances of invertebrates. Do you think that it would be able to do that?
I think the problem may be related to the resolution of the cameras, because usually organisms would be smaller. So when you are using machine learning techniques, usually you need to have a ground truth data set in which you know that this individual belongs to this species, etc. So it has to be created for your data set so that your machine learning algorithm can learn from it. So here, the problem I would see would be to be able to create this ground truth data set. It means that an expert should be able to identify the species of the invertebrates from the videos, from the images. And if it's too small, for instance, you cannot do the identification properly only from the images. You need to have the specimen to be able to check more precisely to which species it belongs to.
Thank you very much. Any other questions for Sakina? I'm still not seeing any. Oh, hold on, there might be one. Yeah, from Ana Lopez in the chat. She asks, would you be able to provide an example of a potential bioindicator to assess ecosystem condition?
So I don't have an indicator that would be already available right now. What I see would be more to be able to relate, for instance, the diversity we can estimate from images or from genomics to the quality of the ecosystems. So it has to be created and to be tested. And the difficulty here would be to have an indicator that would be available or usable for the whole European seas, because for sure you will not have, for sure you will not have the same species characterizing the good environmental status from the North Sea or from the Mediterranean Sea. So here what we need would be to have a coordinated study to develop that kind of bioindicators.
Thank you very much. So I think we'll let the baby go back to sleep again. There's one more question if you are prepared to answer it, from Raisa Meyer from Avi. Could you expand on the indicator example? Yeah, so how are they developed and major challenges? I think you've just done that, but if you want to add something else, go for it.
So for instance, what we have been doing in Villefranche, it was to relate the diversity we could observe from the images, from the plankton images, to the environmental conditions. So you can then provide models, statistical models that are able to relate what you observe to the environmental conditions, for instance. So that's the kind of thing that you can do. I'm more, what I know more is related to the plankton. Of course, if you want to look at the benthos or to the fish components of the ecosystem, then I guess that the tools would be different. But something that may be able to cover a wide range of organisms would be the genomics datasets. So from this, you can use meta-barcoding to identify the species that are present in a given samples. But then what you need, again, is to be able to relate what you observe to the ecosystem status. So here, one of the major challenge would be to relate metagenomics data to environmental conditions and to the status of the ecosystem. Is it in a good condition or in a bad condition?
Thank you very much. Okay, so I think we can go on to the panel discussion. If people have more questions, please put it in the question and answers, and Sakina can answer them after we've gone through a round or two of the panel discussion. So moving on now, our panel discussion this afternoon will consist of 4 speakers. And as I did this morning, I will introduce one of the speakers and ask them a question, and then we'll go through a round of that. Okay, so I'm going to start with Anne Teller. So Anne is a senior expert in biodiversity in the biodiversity unit of DG Environment of the Commission. She's got a background in forest and land management and experience in environmental policy and ecosystem assessment. So Anne, I don't know if we can see you. Can we see you? Can we see you? We can't see you yet, but I will ask the question.
Yeah.
Yeah, there we go. There we can see you. Okay, so my question to you is, what is the most pressing questions that the EU biodiversity in the EU biodiversity strategy, and how do you think big data and artificial intelligence can help address them?
Thank you and good afternoon, everybody. So thank you for having invited me because as you just said, Sheila, I'm a forester by background, so I'm not a marine biologist. But since I've been working on the knowledge base for the EU biodiversity strategy, we had to look at all ecosystems in Europe, including marine. So I learned a lot through this process. And so I'm very proud to say, by the way, that on Wednesday, so 2 days ago, the first EU-wide ecosystem assessment was released, officially released. It has, I think, 500 pages of text and the equivalent of annexes with all the data used. So I can send you the link. And if you're interested in the marine chapter, please have a look. Many people think it's a terrestrial one. No, it's not a terrestrial one. It's terrestrial and marine. So that's important for you to know. But and of course, the marine is the biggest area it's the ecosystem with the biggest area. So it's quite a substantial element. But what I learned through this process is that while it's the biggest, it's still the least known. And therefore, I mean, we looked at, for instance, the data that would come from the reporting and the legislation, the Marine Strategy Framework Directive and the Habitats Directive. But that was quite disappointing, because then we realized that, for instance, only in the Habitats Directive, you have in the annexes, you have some marine habitats, but they cover only 9% of the total marine area, which is nothing. Huh? And in terms of conservation status, they are very bad. I think only not even 3% are in favorable conservation status. And talking about good environmental status under the MSFDs, we don't know. That the simple answer is we don't know. So I was, while what we know is that, Sakina was just very nicely presenting, that the pressures are still there and very high. So it would be very important to better know, how this ecosystem is doing, and what are the main pressures. That's something, but also what are the impact of these pressures on its health and on the services, the multiple services that it provides, and the cost, or the cost of non-action. So that's something that we would like to further develop in the years to come. And so that's why I was so excited to be invited today, because when I looked at the brief, I saw that there are unique opportunities now in terms of big data, in artificial intelligence, and so on, to maybe change the game in the future, and really to catch up with terrestrial ecosystems. And so, as Sakina was showing for us at the Commission, the strategy is calling for ambitious objectives on protection, 30% protected areas in the sea, out of which 10% should be strictly protected. So where best, we shouldn't have a convenient designation. We should really have protect what is most valuable. We also have a restoration target, and there I want to add to Sakina's presentation that we are working on a legally binding instrument for restoration, because our colleagues, for instance, for the marine policy, were saying that with the good environmental status is too broad. They need to fine tune, and they need to put more emphasis on certain habitats or certain species. And so that's what the restoration legally binding instrument will try to correct. And so we are now looking at different habitats with the information we know from different sources, like red list and so on. And so should we take in priority seagrass meadows or nursery habitats, coastal wetlands, if we look at flood protection and climate, kelp forest, coralligenous habitats, and so on and so forth. I don't have to tell you what you know better than me. But so we are discussing this right now, what needs to be protected legally. And then also in terms of species, there are, of course, the flagship species like sharks, whales, turtles. There are also some umbrella species like the anadromous or catadromous, eels and sturgeons, which could then maybe indicate an improvement throughout the whole freshwater and marine ecosystems and terrestrial, because everything is interconnected. So should we go for passive or active restoration? That's another point which is very relevant in the marine area. So to finish, I want to say that within the new governance framework that Sakina was referring to, which will try to have more consistent policy making, more integration of sectors, of stakeholders at different levels, from international, EU, national, and local. There is also the need for a strong monitoring and reporting system, which will seek to have more accountability of member states in seeing whether or not they are acting as they are committed and whether or not the actions they take are really delivering, with the opportunity to have corrective measures. So the strategy is for 10 years, but it can change within the 10 years if need be. And so we'll see, today is the day where the Environment Council will adopt its conclusion on the strategy. So we will see what remains. But so far, what we understood from the Commission side is that at least the protection restoration targets are still in. So thank you very much again.
That's wonderful. I'm glad to hear that. Okay, so my next question is for Patrick Roose. Patrick is the operational director of the natural environments for natural environments for the Royal Belgian Institute of Natural Sciences, ARBENS, I think is easier to say. He's got a background in environmental analytical chemistry and marine chemistry, monitoring and management. So Patrick, my question for you is, what is the role of big data and artificial intelligence in monitoring the marine environment under the Marine Strategy Framework Directive?
Yes, thank you, Sheila, and thank you for having me. Good afternoon, everybody. I could be very brief and claiming that there is absolutely no role currently for artificial intelligence or big data. I would be stretching it a bit because remote sensing is sort of big data treatment as it's coming from satellites, and that is playing currently a role. NMSFD and OSPAR matters. So this is happening currently. But allow me to elaborate a little bit on this. I think there's a really serious, big role for big data and artificial intelligence. What we do now is we have an indicator-based approach where we go out at sea and have point samples, and you try to estimate the status of the seas from those samples. So we need to extrapolate. And there are pitfalls in that. We hope to have the right indicators. We hope to have indicators that tells us if the system is changing according to measures taken or human-induced influences, whatever. So we really try to do that. Now, the objective of the Marine Strategy Framework Directive is to assure good environmental status for European seas. So that's the basic question. So we want to know what the status is, and is it changing because we are having an influence on it, or because we have taken measures to improve it. So that's really the key question here. Approaching this solely from indicators has some limitations. So having a system, and as Sakina has given an excellent talk about that, if you have a system in place which allows us to get a lot of information, that allows us to establish a pattern, establish a holistic view of the environment in relation to not only the species that are in it, but also the important parameters of it, the dynamics of the water column, the currents, temperature, things like that. And that allows us to establish a picture, an image, and a pattern in the ocean, in the seas, that we can use as a basis to see whether change is happening. If systems are changing because the model predicts it, our algorithms predict this, we can go in with shifts, we can go and do in-depth sampling and use the indicators that we use now. So I think we need to go for a combination of the two in the future. We need to have, on the one hand, holistic approaches which are based on big data and what we call augmented observatories, which were already mentioned by Sakina, in combination with in-depth sampling, where we use research vessels to go to spots in the sea or places where we see change and we want to explain it. So that is, for me, the future of big data and artificial intelligence, machine learning, things like that in marine sciences. So I'm a very big fan of going in that direction, really.
Thank you very much, Patrick. Wonderful. So our third speaker is Patricia Cabrera. She works for the data center at the Flanders Marine Institute, or VLIS, it says in her name there. And she's involved with the Blue Cloud project. She's leading the phytoplankton, zooplankton, essential ocean variables demonstrator for Blue Cloud. And she's got a background in marine biology and experience in working in biodiversity. So my question for you, Patricia, which is on the next page, is what are the main challenges in using biodiversity data to achieve the biodiversity strategy objectives, and how are you overcoming them using big data?
Okay, thank you, Sheila, for inviting me here, and good afternoon to everyone. So that's a very good question. And actually nowadays, with the recent advancements in ocean technologies and instruments, but also in fair data and science, we are producing a lot of observations, and also marine data is easier to find and it's more accessible. So for instance, and as Sakina was explaining in the video, imaging systems are more often used nowadays in the marine domain, and they're producing huge amounts of imagery data. Now the challenge here, the key to solve this challenge is using machine learning and artificial intelligence, as we can determine, identify and quantify species with the developed algorithms. And with this, we can determine abundances, diversity, biomass of the plankton communities in a much more efficient way. Now, also as mentioned by Sakina, one of the objectives of the European Biodiversity Strategy to protect marine ecosystems, and especially those of interest in the ones sequestering carbon. So here, that's why it's a very good example, as phytoplankton are essential drivers for biogeochemical processes and carbon fluxes in the ocean. And also both phyto and zooplankton have been tagged as essential ocean variables and essential climate variables by the Global Ocean Observing Systems. Now, concerning the other objective to protect at least 30% of the European seas, here again, the role of big data is very important, and it can help us to improve our knowledge in marine bioindicators and key species. And to achieve this, is very important that we integrate and harmonize different data sources from multidisciplinary fields, and that these are made available, interoperable and accessible for the community. So in this aspect, is very important the direction we are taking, and with all these new the European data infrastructures, like all the lots from EMONNet, but also established research infrastructures as LifeWatch, ERIC, and also European Ocean Open Science Cloud, like Blue Cloud, the project I am working. And EOSCLIFE and EMBRIFER play an important role in achieving these objectives.
Thank you very much, Patricia. Okay, and then our final speaker is Martin Appeltans. He's the Marine Biodiversity Focal Point for UNESCO's Intergovernmental Oceanographic Commission, or the IOC for short. And he coordinates the Ocean Biodiversity Information System, or OBIS. His background is environmental biology, and he's worked in WORMS, the World Register for Marine Species Databases, LifeWatch, and EMONNet, which we've heard about already today. So my question for Ward is, how do the objectives of the UN Decade for Ocean Science for Sustainable Development align with the EU Biodiversity Strategy, given that the IOC is kind of in charge of that? I thought that would be an appropriate question, and I think you've got some slides for that, if I'm not mistaken. So
yes,
get the slides.
Okay, these are my slides. Do you hear me correctly? Right. Okay.
Yes. Yes.
Well, yeah. Thank you very much, Sheila and everyone at the Marine Board. So yes, IOC was tasked by the United Nations General Assembly to develop the implementation plan for the UN Ocean Decade, Ocean Science for Sustainable Development, and I think most of you know that we aim to start on the 1st of January next year. So in a nutshell, the decade implementation plan is really about doing the science we need to go to the ocean we want. So from the ocean we have to the ocean we want. And there are a number of decade outcomes. So we'll want to achieve a clean ocean, a healthy and resilient ocean, a productive ocean, a predicted ocean, a safe ocean, an accessible ocean, and an inspiring and engaging ocean. The objectives is to do the science, to identify the science that we need to do, to build the knowledge. What knowledge do we have? generate that knowledge and increase the use of that knowledge. The decade also, implementation plan also identified a number of challenges. Go to the next slide. Those challenges, those 10-decade challenges, they are dynamic. I mean, they might change throughout the decade, but they very much relate to the strategic objectives of the EU biodiversity strategy. There's almost a one-to-one relationship I could see by reading the two documents. So addressing pollution, also in the biodiversity strategy, it's about reducing pollution. It's about restoring the good environmental status of marine ecosystems, also building resiliency. The decade talks about optimizing the role of the ocean to sustainably feed the world's population. I think also in the EU biodiversity strategy, there's a strong wish or plan to create a new action plan to conserve fisheries resources and protect the marine ecosystem, starting from 2021. The decade talks about the blue economy. Also, we heard about the European Green Deal already today. Talking about the ocean climate nexus, also Europe as the European Climate Pact. So the biodiversity crisis and the climate crisis are intrinsically linked. The decade talks about multi-hazard warning systems. I didn't really find that very clearly back in the biodiversity strategy, although it talks about addressing invasive alien species, which is a hazard. The decade has a very strong focus on doing ocean building the ocean observing system, developing a digital atlas of the ocean, and building capacity development and accessing data, using data information, and using the technology. I found that more in the biodiversity strategy under improving knowledge, education, and skills, and building the sound science to underpin the policy. Also, the biodiversity strategy talks about developing new governance framework to enable a transformative change, and that's also very strong in the decade. UN decade is not doing science for science, but it's for sustainable development, and we can only build a sustainable world if we make a step change in the human relationship with the ocean. And building that ocean literacy is cutting across and a very strong element of the decade. Next slide, last slide. So the EU biodiversity strategy also talks about the BBNJ agreement and establishing 3 protected areas in the Southern Ocean. So the decade doesn't have a policy prescriptive element, so we don't really mention that. Although, of course, the elements and the activities and the actions under the decade can support a new BBNJ treaty. And we published a recent paper a few weeks ago, what IUC can actually contribute to BBNJ. We launched a call for decade actions on the 15th of October. Will be open until 15th of January. You can find information on the Ocean Decade website. The link is there. And if there are further questions on the decade, I'm happy to answer. I hope I can answer them.
Thank you very much, Bart. Okay. So that was the first round of questions. I'm going to go to our second round. I see we've got some open questions, but I'm just going to quickly ask these, and then we'll go to the questions that have come in from the audience. So I've got a question here that I'm going to ask to Patrick and Sakina. So the question is, given that the majority of species in the ocean are undescribed, how can big data and artificial intelligence help us to measure biodiversity? I know it's a terrible question, but it is a really important question, because I know that the people who work on species diversity really have a problem with this. So Patrick and Sakina, I don't know who wants to go first. Sakina, if the baby is quiet, maybe you want to go first.
Okay. Yes, indeed. For instance, if you look at the metagenomics data for the plankton, you just take a drop of water in the ocean and you look at all the genes that are present. And actually, half of them, we have no idea to which organism they belong to, neither which kind of function they assure. So here the problem is really important, because when you are using machine learning technique, as I mentioned it, you need to have the ground truth information. But yet, for instance, what we did recently with our PhD student, Emile Faure, using the Terra Ocean metagenomics data, was to exploit what we called MAGs. That's genomes that have been assembled from metagenomics data and that belong to organisms that can be cultivable, but also that are uncultivable or that we don't know at all. So that's a way to access the part of the diversity we don't know. And with machine learning techniques, we were able to identify the main drivers of the distribution of those MAGs. And that's, I guess, one way forward to better understand how the diversity in the ocean is distributed and to which drivers it responds. So that's one way to access also what we call the genomic dark matter, so the part of the data that we don't know at all.
I learned a new word, genomic dark matter. Great. Okay, Patrick.
Sorry for the microphone. Yes, I actually agree with Sakina. We need a philosophy change almost. We're still somehow stuck in the 19th century where we go out at the sample and try to analyze the sample in depth, and from the species we find in samples and then we take samples of certain patterns, we try to estimate what biodiversity is like or how it can be described. I think we need to combine this with the more innovative techniques that Sakina has been describing. If you want to estimate where we are, what's the status of biodiversity in oceans and seas, we need to move away from the classical approach and start incorporating these novel approaches so that we come to a better assessment of the diversity in a larger scale with a faster method that gives us much more data, and then via algorithms and artificial intelligence, machine learning, what have you, come to establish these pictures, if you like, of biodiversity and see whether they change, because what you need to know when you want to manage a system is there change and what's causing the change? And that's a crucial question. And I'm not quite sure. In fact, I'm quite convinced that it's very hard to do with the current approaches. So I'm very much in favor in going for these innovative new approaches in this.
Thank you very much, Patrick. Okay, and then a question to Ward, Patricia, and Anne. How might big data, digitalization, and artificial intelligence play a role in regionally and globally integrated data products for marine biodiversity indicators? I'm not sure who wants to go first, but maybe Anne, because you spoke first. So if you want to go first, that'd be great. Can't hear you, Anne. Hold on. Still can't hear you.
Yeah, okay. Okay. I have to click twice. That I should remember. Yeah, I mean, we are, I fully agree with all what was said. I think it's the same for terrestrial, by the way. We need a mental shift. We still need, I'm a strong believer that we still need data from, ground truth data to validate and so on. So we shouldn't underestimate that and the resources to be spent on that, which is always difficult to ensure. But we are working hard with DG Research to get financial support for that, because, as you know, it was a kind of vacuum, because the research was saying it's not research, and policy was saying it's not policy. So, but we need monitoring for policy. So this is hopefully going to change. I think the marriage of these old, as was mentioned by Patrick, old techniques with the new ones is really the way forward. And we have huge opportunities as policymakers. I must confess, we are not always aware of these very fast developments. And it's also for you to communicate that to us and to share that with us, because we are really willing to improve that, especially because we live in a very changing context with climate change, and therefore we need to also be able to predict, how things will evolve and then correct, through time. So we really need to change our way of making policy, and therefore also using the data for policy making, the evidence, and We are, for instance, there is a project, Europa Bon, it's called. So it's a network to try to monitor the biodiversity variables, essential variables, and marine is part of it. So freshwater and marine. And that's what I also would like to say, is that the way policy has been defined is, in the past at least, is very silo. So marine people, they work on the marine environment and the freshwater and so on. While we know that at the end of the day, all what we do on terrestrial and rivers will end up in the sea. So if we don't have a more integrated understanding of what's going on, none of us will get there. So I think it's very important also to integrate these models and this data to have a better understanding of what's going on. So thank you very much.
Thank you very much. Okay, and then I don't know who want to go first. Patricia, Ward? Ward, go first. Okay.
I think I can
Yep.
continue. Yes. I think we heard a lot of the things about big data and artificial intelligence, and I'm not going to repeat all the things that have been said, but I want to add one extra element that I don't think we've said already today. And we heard about Andre and who worked for Google. And so I would like to say that I think we should start using the internet for what it was designed for. And I think many of the existing solutions that use big data and artificial intelligence, they still use centralized systems for integration. But the problem is that they often can't scale and they can't be as responsive as looking for answers in a global digital commons like the internet. Our current data systems are very much built on the concept of a hub and spoke model, where multiple nodes feed into a single hub, a centralized data system. The new vision here is that we should use the web as our collective hub. Let me clarify myself. Nowadays, I can ask Google almost anything, like the weather forecast or where is the nearest pub. Google is using big data approaches and can do that because of the way the data is published on the internet. In contrast, the information in oceanographic databases, they often remain hidden to these big data services. So I want Google to be able to immediately reply to questions like, when was the last sperm whale sighting in the North Sea? Or what is the average seawater temperature in October off the coast of Scotland? Currently, Google can only answer that question by providing links to approximate sources that hold those keywords. However, I think this should be perfectly possible through systems like OBIS or IMONet if we use high quality semantic resources and extend those in collaboration with the developers, because they are not totally ready in order yet. And that we publish the information using semantically enhanced linked open data. And we have to continuously test that interoperability and the integration is actually working. So the most interesting part of this approach is that we will be in a power, but the interesting thing is that the power will be to interconnect multiple nodes and then be able to answer more complex questions that require the combination of information from more than one information source. So ultimately, the success of a data system will be measured not just by the number of users of a given node, but by how many different nodes were used in a single user query. So this is the concept of the DigitalOcean ecosystem, and Pierluigi this morning already I posed some questions about this and already shared some links in the chat box this morning. So the DigitalOcean ecosystem that will be the foundation of the Ocean Data Information System, or ODIS, for the UN Ocean Decade. So each data system can be IMONet or OBIS or any other system. They can become a node in this distributed system and fulfill their own niche in the DigitalOcean ecosystem. I can also share a link, a YouTube presentation by Pierluigi in the chat box, who explains the concept. So in conclusion, so big data will not be about building a bigger local database, but making sure that our AIs, or the artificial intelligence, can discover and pull data on the web and then discover marine indicators that we don't know exist yet. So ultimately, asking about the status of the marine environment should become as easy as asking Google where the nearest pub is.
Thank you very much, Ward. I'm very much looking forward to finding that question, because at the moment asking where the pubs are is absolutely no use because they're all closed. Okay.
Correct.
So the last person to answer the question is Patricia.
Yes, well, I'm gonna complement Ward answers because I totally agree, and this is actually how in the Flanders Marine Institute that is our vision and how we're moving forward. And I would say that just before that, the big step is also to bring together all these nodes, all this European data management infrastructure into one space. And this is actually the purpose we are doing in Blue Cloud, which is federating leading European marine data infrastructures. And the tricky part here is how to combine all this data, for instance, Copernicus satellite data with Argo floats and biodiversity data all together to produce, to have products that we can use for the policies. Now, Blue Cloud will also provide discovery and access to this multidisciplinary data, but also brings the opportunity to perform high computational analysis by providing workflows with examples in the form of demonstrators that will be available for users that can use or reproduce and build up further on these products. So this will allow us to explore the existing sources in a more efficient way. And just to conclude, it will be also very important that all these products and results are used by marine policy advisories like the European Biodiversity Strategy.
Thank you very much, Patricia. Great. Now we have some questions in the question and answer. The first one I'm going to ask is to Anne. And the question is from Anna Akimova, and she asks, you talked about different areas within the marine ecosystem, so biodiversity hotspots, nursery areas, and so forth, how to prioritize their protection. Are there lessons that we can learn from the protection of terrestrial ecosystems, which obviously have had a longer history?
Yes, for the terrestrial, we had this what we call biogeographical seminars, which was mixing scientists, officials and stakeholders, so putting the evidence together and then discussing, you know, what best to protect, and also with a sense of feasibility, of course. So this process will now be completely revamped in view of the new biodiversity strategy, and will be used, you know, to discuss with the scientists and the stakeholders what should be protected in priority to get to the 30% protected areas objective, and also what should be strictly protected to ensure that that the whole system can survive. So this is what I know.
Thank you very much, Anne. Okay, so then we have a few questions that were kind of answered in the question and answer in text, but I will ask them again. The first one, just because it'd be nice to hear people's responses. The first one is from Justin Buck from NOC. And he says the need for data harmonization has been mentioned by many of the panelists and presenters. Are there any other requirements on data delivery in addition to the existing FAIR principles and the trust priorities that were mentioned this morning? Or are those enough to facilitate these big data applications? And this was asked to everybody, so anybody can answer, but I think Patricia has given an answer in the question and answer. So if you want to speak about that question, then other people might also have an answer.
Sure. Well, as I said, I think it should be enough, but it is not easy. It really takes a lot of time and a lot of work and effort. I think we're moving forward a more fair data science, and if we all follow it, it should be enough. with these guidelines. I don't know if someone else would like to add anything.
Anybody else? Sakina, Wart? I saw you. No?
Yeah, so I'm trying to dig up the data chapter of the UN Ocean Decade Implementation Plan, and it refers to the FAIR principles, but it also refers to the trust and the care principles. I'm not totally familiar with the trust. I think it's related to transparency, but in addition to, there's also the care principles, who who supports and considers and takes into account the respect towards traditional and knowledge from indigenous people, and that's I think that's in addition to the FAIR principles. Yeah, respecting the traditional knowledge.
Thank you, Wart. Anybody else want to have a go at that one? No? I will actually add one that I don't know that I've heard, or maybe it's been mentioned in a different way. One of the things that I think is a problem for getting all of the data into these big data combiners, if that's the right word for it, is often there are scientists out there who keep the data on their own computers because they've been burnt before, and people have had their data and published stuff without acknowledging them or something like that. So how do we get that trust, the trust in the research environment where people have spent a lot of time and effort to collect data, but they don't want to put it on these big databases because they might not be acknowledged for the large amount of work that they've done. Don't know if anybody wants to have a go at that, but that's my Sakina.
Yeah, for instance, if you publish your data set in an open repository, such as a Pangea, things like this, like that, you can get a DOI, and you can get a way to cite your data. So I think that more and more people are sharing their data sets, and they are acknowledged for it, and especially young scientists. I have to mention it because I think it's a way of a new way of thinking, doing science and sharing the scientific results and scientific data. And I think we are going on the right track right now.
Thank you. Anybody else want to have a go at that? Otherwise, we'll go to some of the other questions. I'm mute. Somebody's put the care principles in the questions and answers. There is also a question from NP, which is very cryptic. And I think Patricia has answered this. How can we easily find the data sets from the European data infrastructures? Patricia, did you want to just give that?
Yeah, sure. So we have all these European marine data infrastructures that they have their own metadata catalogs that help you to find easily these sources. But here where Blue Cloud plays an important role is because it will federate all of them together, and it will make it easier for us because we will have everything just in one space, and easy to, with the examples, with the demonstrators, we will be able also to combine the different ones in an interoperable way. So I would say that is the way.
Okay, does anybody else want to answer any of those questions? I don't know if there's any other open questions. They've all kind of merged into one now, so I think we've covered all of them. And we're virtually on time, so I don't know if anybody else has any other questions. I think
Sheila, can
yeah,
I?
Wart, yes, go for it.
Just to expand a little bit on where can we find data sets. So as one of the first steps in building the Ocean Data Information System for the UN decade, IUD is building a catalog of data sources and information sources. It's not the aim is not to replace it, to replace other metadata repositories or become even a metadata repository. It's really about building a catalog, an index that can guide us and discover data sets, data sources, information sources of all kinds, to then build that digital ocean ecosystem. That so the architecture that will be developed can search data from those data systems when they are connected to the architecture through semantically enhanced open link data. So to the catalog, the Otis cat, I can share the link. It's really, I mean, there are more than 1,000 sources already described there. And if there are sources missing, I really advise everybody to add information to it. So to make sure that our Ocean Google that we want to develop is harvesting from those data sources.
Thank you.
I'll share the link.
Yeah, that'd be great. I have one last question, and I know that we're just on time now, but I have one last question that came out of this morning's presentations, and that is, I'm not 100% sure how much in the Open Science Cloud and how much in this OBIS database that you were just talking about, Wart, how much are we actually incorporating the human dimension, so the human uses? And if you really want to be able to manage biodiversity or the human impact on biodiversity, are you linking up with the human data? You know, not just the fishing data, but you know, movement of people and shipping and all of the other things that will be important in order to really address the biodiversity strategy. Patricia, Sakina, Patrick, anybody? Wart?
I think that's a very good question, and it's certainly not. I mean, it's again the challenge that we are all facing. And for example, with OBIS, I mean, how much can OBIS do? I mean, and how much more can we take with the very limited resources? That scalability problem is I think we are all facing. Everybody is building a data system, and I think it's really important that we just build our own niche, and everybody has their own niche, and but we need more information on the use of the ocean. I mean, the human use of the ocean. I think IMONET is quite ahead. In Europe, with IMONET is quite ahead compared to other parts of the world. I think. I mean, there's quite a bit of information on human uses through IMONET, different lots. But then the challenge is in combining that information and answer questions. And that's, I think, the challenge that we have now in the next 10 years. And certainly something we need to address as part of the decade and get a sustainable ocean by 2030.
I was going to actually also mention where the IMONET lot for human activities. And I also think that the problem is on combining all this information. But there is a specific lot for these human activities at sea.
Thank you very much. And then I will also just add, and I know we're completely over time, but I will add that the other thing that I think we need to think about is linking it with the terrestrial data. We need to link it to the pollution coming down the rivers. We need to link it with the movement of tourism, because those things will have an impact on the ocean. And if we don't do that, then we're only looking, you know, one way. I don't know if anybody wants to add to that. And I don't know if we're doing, how much of that is happening. I know at the JRC, they're at least linking river flows and pollution from river flows to ecosystem models. So that's happening in that sense, but I don't know if, I think if we want to do this properly, we need to do it at this level, at the Blue Cloud level. So, or the Open Science Cloud. And did you want to respond?
Thank you, Sheila. Can I say something?
Yes, please do.
Yeah, because you took the words out of my mouth. I mean, from the policy side, I would really recommend, I mean, data is important. That's clear. But we need to act. And so from the policy side, we need a story. We need an integrated story, just as you say, linking what we do on terrestrial ecosystems, through freshwater and marine, in order to have some action. And I remember one of the top managers here was wondering why suddenly we had this, legislative proposal to ban plastic for years and nothing happened. Suddenly we need it, it tomorrow. And it was because of these images, which were very, very powerful, that the people could understand that their plastic bag that they are using when shopping suddenly ends up, in the middle of the ocean and makes a full mess. And he was saying we need more stories like that, because then, it really steers policy action. And I think that maybe because we are, and I put myself in, we are very much science oriented, that we like to have, all the details along the data and so on. But we should also, spend some time to tell stories which integrate different elements together. So thank you for asking the question, Sheila.
Thank you. Okay, so I know we're over time, but I will mention that in the chat, which I don't know if everybody was able to see, or maybe it was, there was a comment from Jeroen who spoke this morning to Wart, asking if you talk about transparent data access from any number of sources to a shared catalog rather than building yet another data warehouse that duplicates. And then I think, Wart, you responded, but did you want to say that in words?
Sorry, I was typing a response in the Q&A. I think I provided the answer in the chat box, right?
Yeah, but I didn't know if you wanted to just say it so that in case people can't see it. Yeah. I mean, yeah.
So, so the question from Jeroen Steenbeek. Yeah, so ODISCAT is indeed, it doesn't want to duplicate any other metadata repositories, and it's really not about fully describing all the information from a data system or a data set. It's really about how is that those data sources, how are they, what is the data license, how can they be accessed, are there web services, APIs, and what is the data standards that you're using? Do you use semantically enhanced ontologies? All the information that we need that is required to connect the data sources to a global hub like the web.
Thank you very much. Okay, so I'm going to close. And I'm going to close by the comment that Federico Redondi made in the chat, basically that there is a big need for storytellers in the scientific field. And I would say in any scientific field. If you've ever read a scientific paper, we could definitely do with better storytellers. So I will leave it at that and just say thank you very much to our speakers. It was a great panel, and I think I learned a lot. And to say that we will have our next session starting at 3:30. So please go and have a cup of coffee, go and enjoy the sunshine if you happen to be in Ostend or somewhere else where the sun is shining. And we'll see you back at 3:30. And thank you very much to the panel.